Here's a quick review on ionic compounds, including binary ionic compounds, ternary ionic compounds, and transition metals as well. So what I would recommend that you do at this point is I'm going to show you all 20 of these if you want to take a picture of them. But here's the first 10 right here. So you could pause the video at this point and write the chemical formulas for those 10. Okay, and then we're going to have 10 more here. So it moves down here. There we go. So we're going to have 10 more starting at number 11, K2CO3, going down to NH43PO4. So, and on those 10, obviously we're going to be writing the names. So if you would like to, again, pause and then take a picture of those, you can do that. And then try those first, and then come back and then watch the rest of the video where I go over all of these. So there's the first 10 names where we're going to write the chemical formulas. And then here's 11 through 19. And then one more is number 20, NH43PO4. Okay, and like I said, I'm going to go over all of these now. So number 1, magnesium acetate. We're asked to write the chemical formula for that. So again, anytime with an ionic compound, we always start out by writing the name or the chemical symbol with its charge. So magnesium has a +2 charge, and at this point, I've got my periodic table here next to me. I've got my list of those ions that I was given in the notes. So I have both of those right here next to me. So magnesium, I look at the periodic table, I see that it's in the +2 column, and then acetate, I look at my ion sheet, and I see that it's Mg, or it's at C2H3O2 minus. So I take those two and I switch them, and I get Mg, and then in parentheses C2H3O2, and then a 2. Okay, iron 3 carbonate. So that's telling me that iron has a +3 charge, and therefore carbonate, I go to the ion sheet and it is CO3 2 minus. And then, like always, I take those charges and I switch them. So I need to have 3 carbonates. So be careful. Put that whole carbonate in parentheses and then put a 3 outside of it. That is the correct response. Strontium hydroxide. Strontium has a +2 charge. Hydroxide is OH minus. So again, the 2 is going to come down here. Again, the mistake that students make is they oftentimes forget parentheses on that hydroxide. Make sure you put that on there. Okay, so SR parentheses, OH parentheses 2. Ammonium oxide. Ammonium is NH4 plus, and then oxygen has a 2 minus charge. So the 2 is going to come down here. So we're going to have NH4 2, and then just the O. Zinc peroxide. Zinc is one of the ones that always has a charge. Even though it's in the transition metal area, it always has a constant charge of +2, just like aluminum's +3 and silver is always +1. And then peroxide is 2 minus, so notice the +2 and the -2 cancel each other out. So we just get ZnO2. Number 6, copper 1 sulfide tells us that the charge on the copper is +1. Sulfide, remember, is not sulfate. Sulfide comes from sulfur. So that has a -2 charge. And so that 2 is going to come down here. We're going to get Cu2S. Number 7, manganese 5 means that manganese has a +5 charge. Chloride is not chlorate. It's chloride, which means it's chlorine. So it just has that -1 charge from the periodic table. And you get MnCl5. Number 8, platinum 2 arsenide. Platinum is Pt. And again, obviously you're not as familiar as I am with these. You're looking at the periodic table, finding platinum, making sure you know what its symbol is, and then we put its charge on there. Arsenic, we want to put Ar, but that's argon. So arsenide comes from arsenic, which has a -3 charge, which means now we switch those charges, Pt3, As2. Okay, number 9, mercury 1 is Hg, with a positive 1 charge. So selenide comes from selenium with a -2 charge. So we get Hg2Se. And then our final one for writing the formula on is sodium phosphide. Sodium has a +1 charge. And then again, most of the time when it ends in IDE, it's an element on the periodic table. There's a couple times where it's not. Here's one of them, hydroxide and peroxide. But in general, when it ends in IDE, you're looking for it on the periodic table. So phosphide has a -3 charge. And so the formula is just Na3P. Okay, so there's the first 10. Number 11 says K2CO3. So again, like with all ionic compounds, it's identifying that's the positive, that's the negative, positive, negative, positive, negative, positive, negative. Okay, and then just writing out the positive is potassium and the negative is carbonate. Now, if you're not sure if it needs a Roman numeral or not, leave a little space there to put one in if you need one. Okay, but then you look at potassium on the periodic table, you're like, no, potassium's in the +1 column. It's always +1. I don't need a Roman numeral. I'm not going to mark it wrong if you leave kind of a random blank space between them. Okay. Number 12 is nickel, NiCkel, and SO4 is sulfate. Now I look and I find nickel on the periodic table. Doesn't need a Roman numeral. Yes, it's in the transition metal area. So sulfate is -2. So therefore the nickel must be +2. But there's 2 nickels. Okay, and if you think about it, if nickel were +2 and there's 2 of them, wouldn't that be +4 all total? It would. You don't want +4, you want +2. So remember, if there's more than one of these, then you've got to divide. So it's +2 divided by 2. So that has to be nickel 1 sulfate. Okay, number 13, Ca is calcium. And HCO3- is bicarbonate. Okay, and then I look, calcium's in the +2 column. It's always +2. I don't need a Roman numeral. Okay, number 14, V is vanadium. And O is oxide from oxygen. And then I look, yep, vanadium's a transition metal. Oxygen's -2. There's 3 of them though, so that's -6. So therefore the vanadium would have to be +6, and since there's only one of them, it's got to be a 6. So vanadium 6 oxide. Okay, number 15, CO is cobalt. ClO3 is chlorate. And then I look, yep, cobalt's in the transition metal area. So I go to chlorate. Chlorate has a -1 charge, and there's only one chlorate. And since it has a -1 charge, the cobalt has to be +1. So it's cobalt 1 chlorate. Number 16, Ag is silver. NO3 is nitrate. So that is silver nitrate. Silver nitrate is a clear liquid. It's one of those ones that if you get it on your fingers, it will like stain your fingers for a couple of days until those skin cells go away. So if you ever get some on you, it's not a big deal, but at the same time, it will turn your skin kind of a darker color for a couple of days. Okay, now with silver, do I need a Roman numeral there? No, I do not, because remember, aluminum, zinc, and silver are the 3 in that transition metal area that never change their charge. So it's just silver nitrate. I leave it like that. Okay, number 17, CSBr. CS is way over in that first column in the alkali metals. And Br is bromine. I change that ending to IDE. So that is cesium bromide. I look, cesium's in the +1 column, so no Roman numeral needed. Number 18, AUF. Easy way to remember the chemical symbol for gold is AU. Bring me back my gold. If somebody steals your gold, that's what you would say to them, right? AU, bring me back my gold. Okay, so gold and then fluorine becomes fluoride. And then gold absolutely needs a Roman numeral. So since fluorine's -1, the gold is therefore going to be +1. So that is gold 1 fluoride. And then number 19, lithium. then nitrogen, remember, becomes nitride. And then I look, lithium's in the first column. It's an alkali metal, so it does not need a Roman numeral, so it's just lithium nitride. And then our final one, NH4, is ammonium. And PO4 is phosphate. And clearly not a transition metal because it's not a metal at all. So it is just ammonium phosphate. And those are just, again, 20 different practice ones that hopefully you can look at. If you have any questions, make sure that you ask me. Okay, but this is really, really important to doing a whole bunch more of things that we're going to do in chemistry later on this school year.